So for number 52, we want to see if this sequence here, if it converges. Now a sequence AN, it converges if it tends to a defined number L as n approaches infinity. So what we're going to do here is we're going to take the limit as n approaches infinity of our AN, so n minus square root of n plus 1 times square root of n plus 3, and see if this spits out a number. Before we do anything, I'm just going to simplify this a little bit so that it's easier to deal with it. So this is going to be the limit as n approaches infinity of n minus, and now I'm just going to join these roots by multiplying them. So that's going to be the square root of, I'm going to multiply them, so n squared plus 3n plus 1n, so plus 4n, and then plus 1 times 3, so plus 3. Okay. So now if we evaluate this, we're going to get the limit as n approaches infinity. We're going to get infinity minus the square root of infinity squared plus 4 times infinity plus 3. We don't actually know what that is, so that's no good. What we're going to have to do here is we're going to have to turn this into a quotient, because quotients make it really easy for us to deal with infinity. And so I want two things. The first thing is I want to turn this into a quotient if possible. And the second thing is I want to get rid of the square root. And the reason that I want to get rid of the square root is so that I can kind of get these terms here that are inside, I can get them free and kind of manipulate them. So what we're going to do here is we're going to multiply by the difference of squares, right? If we have that a squared minus b squared is equal to a minus b times a plus b. So I'm going to multiply this by n plus square root of n squared plus 4n plus 3 over n plus square root of n squared plus 4n plus 3. And the reason that I'm doing this is because of the difference of squares. When I multiply this, so I have, this would be my a minus b, and this would be my a plus b. So when I do this, I'm going to get a squared minus b squared. And so the b, when we square it, it's going to get rid of that root. So when we do this, this is going to be equal to the limit as n approaches infinity of, it's just going to be n squared minus square root of n squared plus 4n plus 3, all of this squared, over n plus square root of n squared plus 4n plus 3. Okay, so that is definitely an improvement for us. And now we're just going to simplify this. So this square and that root, they cancel out. So this is equal to n squared minus n squared plus 4n plus 3 all over n plus square root of n squared plus 4n plus 3. Okay. And then when we do this, this simplifies to n minus n squared, so the n squared disappears. So that is going to be minus 4n and then minus 3 over, that is going to be n plus square root of n squared plus 4n plus 3. Okay. And remember that we're taking the limit of this, right? So if I take the limit of this, I'm still going to get minus 4 times infinity minus 3 over infinity plus square root of infinity. And so what I want to do is I want to divide everything by n, because if I divide everything by n, then I'm going to get a nice number at the top, and that at least helps me simplify it. So I'm going to take the limit as n approaches infinity of minus 4n minus 3 over n plus square root of n squared plus 4n plus 3. Okay. And then what I'm going to do here is I'm going to divide the top and the bottom by n. So I'm going to do 1 over n and then 1 over n. So when I do this, I get the limit as n approaches infinity of minus 4 divided by n is just minus 4, and then minus 3 over n. And then over here, I'm going to get n divided by n is just 1 plus square root of n squared plus 4n plus 3, and all of this divided by n. Okay, and now what I'm going to do here is I want to further simplify this part. And so remember that n is equal to the square root of n squared. These cancel out, right? So what I'm going to do here is I'm going to turn this n into the square root of n squared, so that I can put it in this side, this root, and I can simplify everything. So this is going to be equal to the limit as n approaches infinity of minus 4 minus 3 over n divided by 1 plus, and now I'm going to put everything in the root. So that's n squared plus 4n plus 3, and all of this divided by n squared, which is equal to the limit as n approaches infinity of minus 4 minus 3 over n divided by 1 plus, we're just going to simplify this, square root of n squared divided by n squared is 1, right? 4n divided by n squared is plus 4 over n, and then plus 3 over n squared. So plus 3 over n squared. Okay, so that was quite a lot of work. But once we get here, we are ready to take our limit. So when we take our limit here, the limit of minus 4 is just minus 4, and then minus 3 over n, so that's going to be minus 3 divided by infinity, which just goes to 0, right? So plus 0 divided by, the limit of 1 is just 1, plus the square root of 1 is just 1, plus 4 divided by infinity, that's going to go to 0, right? Plus 3 divided by infinity squared, that's going to go to 0. So then we get minus 4 divided by 1 plus square root of 1 is going to be divided by 2, which is equal to negative 2. So that was quite a lot for us to get to this answer here, which the limit is negative 2. So we have just shown here that, and I'm going to put this in a different color, an tends to negative 2 as n tends to infinity, so an converges. And so that is it for the for this problem where we have to do a bunch of algebraic transformations to get to this limit of negative 2, and then we showed that an does lead to negative 2 as n goes to infinity, so the sequence definitely converges.